Hello, class. 7.4 screencast notes. The quadratic formula. So, starting off with some notes about the quadratic formula before we get into some problems. Let's say given a quadratic equation in general form, and we remember that that would be ax squared plus bx plus c equals 0. The solutions for x are, and now here's the formula. It's a long, crazy formula that you will memorize because you'll use it so much, you'll memorize it. X equals negative b plus or minus the square root. Got ahead of myself there. Square root of b squared minus 4 times a times c. And then this whole thing is divided by 2 times a. Okay, so there's the formula. Now, what is it used for? This formula is used to find the roots or zeros of a quadratic function. Okay, and it's used to do that when you cannot factor. So we saw completing the square as one way to rewrite an equation in another form. We could use that to solve for the roots or zeros as well. And now we're going to use another one called the quadratic formula if we can't factor. So, example A brings us back to some projectile motion problems. It says Nora hits a softball straight up at a speed of 120 feet per second. Her bat contacts the ball at a height of 3 feet above the ground. Recall that the equation relating height in feet y and time in seconds x is y equals negative 16x squared plus 120x plus 3. How long will it be until the ball hits the ground? So in example A, they've already written the equation for you. So remember, the projectile motion equation is ax squared plus the initial velocity times x plus the initial height. So because our problem is in feet, that's why we use negative 16 as our a value. So the equation y equals negative 16, that's an ugly looking x, negative 16 x squared plus the initial velocity was 120 x plus 3, because that's how the height she hit the ball above the ground. They want to know how long until the ball hits the ground. Well, when the ball hits the ground, what's the height? 0, right? So we're going to plug in 0 for y and set this equal to negative 16x squared plus 120x plus 3. Now, if we try to factor, so let's just say I'm going to try to factor this. So I would use the Xbox method. So this is a times c. So I'd have negative 16 times 3, which is negative 48. And then 120 here, because this is b. So I would need two numbers that multiply to negative 48 and add to 120. Now that is absolutely impossible. The biggest numbers that I can get that multiply to 48 is 48 times negative 1. And when I add these, I get 47. That's not even close to 120. So factoring is not possible. This is not gonna work. okay? Factoring does not work. So I could complete the square and then solve using square roots, but since this is a lesson on quadratic formula, we will use the quadratic formula. So, on to the next slide. I'm just going to rewrite this equation. 0 equals negative 16x squared plus 120x plus 3. So, some steps to using the quadratic formula. Steps. 1. Identify A, B, and C. A, B, and C, because we need it for the formula. So if you're written in general form and you're written with the highest degree first, then we have A, B, and C. Plug the numbers into the formula. So that's step 2. Plug numbers into formula. So let's remember what that formula is. X equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. So I'm going to take my numbers and plug them in. So I will have x equals negative b is 120 plus or minus the square root b squared, so that's 120 squared, minus 4 times a, which is negative 16, times c, which is 3, and it's all divided by 2 times 3. Okay. Now the next step, step 3, solve. Now remember, when you solve, you must use the order of operations. And usually, not all of the time, but usually you will get 2 answers. Okay? All right, so let's see. I don't know how I did it last time, but I accidentally copied and pasted, and that would be lovely if I could figure out how to do that again. I think I don't want to select all. I just want to select like a piece. Oh, see, look at that. Copy. And paste. Hey, look at this. I'm getting pretty amazing at this, don't you think? All right, let's erase this. Perfect. So now here's the equation. Let's evaluate using our order of operations. So we have PEMDAS. So parentheses. So my square root pretty much acts as parentheses. So I want to evaluate all of this stuff first, because all of that stuff under that square root is pretty much telling me, do me first. So x equals negative 120 plus or minus 120 squared. Now, got to dig into my notes. 120 squared is 14,400 minus 4 times negative 16 times 3 is negative 192. Okay, this is still divided by 2 times 3. Oh, why did I get 3? Oh no, my first example and I make a mistake. Let's go back. Sorry. Hope you caught it. Hope you're like, Miss Fallon, what are you doing? This should not be a 3. It's 2 times a, and a is negative 16. So good thing I caught it before I kept going. So a was negative 16. Hello, wake up. Okay, so we got to change it here too. This should be negative 16. So I can do that multiplication on the bottom, just get that as a negative 32, just to simplify it so it's only one number. So now inside my square root, remember I'm solving that first, minus a negative, that changes to plus. So I have 14,400 plus 192. So that changes to x equals negative 120 plus or minus the square root of 14,592. And then that's all divided by negative 32. So parentheses, which was my square root, everything under my square root, done. Exponents. Now if you remember, square root is like raising everything to the 1/2 power. So my square root is my exponent. So I take the square root of 14,592, or I can leave it as 14,592 and do both sets of equations here. So what do I mean by both sets of equations? Well, see this plus or minus here, right here? That's telling me that I really have two different equations. I have one equation with a plus sign and one equation with a minus sign. So, what does that look like? Well, if I have my plus sign, then my equation would be negative 120 plus the square root of 14,592 divided by negative 32. And that would be what x equals. However, if I have the minus instead of the plus, then my equation would read negative 120 minus the square root of 14,592 divided by negative 32. And that would be what x equals. So there's how I get my two answers. One with the plus sign and one with the minus sign. And then I simply plug that into a calculator and evaluate. When I evaluate negative 120 plus the square root of 14,592, I hit equals. I divide that by negative 32. X is equal to negative 0.25 or 25 hundredths. When I do the same operations but with the negative or the minus sign out front, I end up with 7.52. So these, both of these guys, are my zeros or my roots. Okay? So, in this problem though, remember, this was a real-world problem where Nora hit a softball straight up into the air. So how long will it be before the ball hits the ground? Well, I can't go back in time, so my time can't be negative. So in this problem, I only have actually one answer, and that's the 7.52. So let's just make a note, because this is, again, a real-world problem. So in this problem, negative time does not make sense. Remember, you have to think about what it is that you're answering. So the ball will hit the ground at about 7.5 seconds after Nora hits it. Okay, and that's where we think about what problem we are actually answering. It can't go back in time, and the ball can't hit the ground at negative 0.25 seconds. It's not possible. So it has to be the positive answer. If this was just a regular old problem, just saying solve this equation, then we would have both solutions. Okay, example B. Example B is that type of problem. It's just solve. 3x squared minus 5x plus, or 3x squared equals 5x plus 8. So example B, 3x squared equals 5x plus 8. Well, right now I can't solve this at all because it's not in any kind of form. If I want to put it in general form, I'm going to subtract the 5x and the 8 over to the other side of this equation so that this whole side cancels, leaving me with 0. And this side will read 3x squared minus 5x minus 8. So I want to solve this. Well, right now I have a quadratic equation equaling 0. From the quiz we just had, we know that if we factor this, I can then use the zero product property and get my solution. So let's factor. Here's my a times c. So 3 times negative 8 is negative 24. And we have to add to negative 5. Well, isn't that convenient? So we see that, let's see, negative 8x and positive 3x. Negative 8 times positive 3 is negative 24. Excuse me. And negative 8 plus 3 is negative 5. So now I can draw my box here, and I would say 3x squared and minus 8 here. I get a negative 8x and a 3x, and then I can factor this. Let me pick a different color. So factoring out of negative 8x and negative 8 is a negative 8. And factoring out of 3x squared and 3x is a 3x. So 3x times x is x squared, and 3x times 1 is 3x. Negative 8 times x is negative 8, and negative 8 times 1 is negative 8. So the factored form here would be 3x minus 8 times x plus 1 equals 0. Using the zero product property, I would say that 3x minus 8 equals 0, or x plus 1 equals 0. Solving, I would add 8 to both sides and then divide by 3. So I would say x equals 8 over 3. Here I would subtract 1, or x equals negative 1. And if I was doing this factoring, this would be my solution. But again, we should know how to do that already, and this time we are using quadratic equation. So let's test and make sure we get the same solutions using quadratic formula. So for B, the quadratic formula, we would first, again, 3x squared equals 5x plus 8. We'd still have to get everything to one side. So we have 3x squared minus 5x minus 8 equals 0. Do you remember our steps? Identify A, B, and C and put them into the formula. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Let's see if I can plug them in right this time. Pay attention, maybe I'll trick you again. X equals minus negative, b is negative 5, so negative 5, plus or minus the square root. Am I going to run out of room? Most likely. Let me just back up a little bit so I can fit it. So x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times a, which is 3, times c, which is negative 8, divided by 2 times a, which this time is really 3. Okay, so let's simplify a little bit here. A negative, a double negative, here is just going to be a positive. So we're going to have x equals 5 plus or minus. And now we start to simplify what's under the square root. So I have square root. Remember, negative 5 is in parentheses, so it's negative 5 times negative 5. So that's a positive 25 minus 4 times 3 times negative 8 gives me negative 96. And this is all divided by 2 times 3, which is 6. So I'm going to continue on, and I'm going to simplify here by changing this minus a negative to a plus. And now I can actually add that. X equals 5 plus or minus the square root. 25 plus 96 is 121 divided by 6. Now, because 121 under my square root, because this is a perfect square, I'm going to go ahead and take the actual square root of 121. I didn't do that in the last problem because it was a big long decimal, and it's more accurate if you just leave it as the square root of a number when it's that in that case. But 121, the square root of 121 is just 11. So I can break this equation up now. How do I want to do this? I'm going to go on to the next screen. So let me rewrite. I had x equals 5 plus or minus the square root of 121 divided by 6. So I'm going to break this equation up now into the two equations. Well, I'm going to solve that first. 5 plus or minus 11 divided by 6. So the square root of 121 is 11. That's where that came from. And now I have my two equations, one with the plus sign, one with the minus sign. So 5 plus 11 divided by 6, or 5 minus 11 divided by 6. 5 plus 11 is 16 divided by 6 would equal, let's see, 8 over 3. Or 5 minus 11 is negative 6 divided by 6, which is negative 1. So x equals 8 over 3, or x equals negative 1. So even if you can factor, you can still use the quadratic formula to get you to your answer when solving a quadratic equation. Because if I'm not mistaken, if I go back, there are the same solutions. Here they are. X equals 8 over 3 or x equals negative 1. Okay, so one last example. Use the quadratic equation to find the zeros of the function, then rewrite the equation in factored form. So we're going to use the same idea. The quadratic equation. I'm going to just jump right into the quadratic formula, although I think that that one can also be factored. But I'm just going to jump in and just practice the quadratic formula. So maybe you want to pause it here and try to use the quadratic formula and get your zeros before I do. Or maybe you want to race me. I don't know. But either way, let's get this last example done. So first step, A, B, and C. Rewrite with the equation x equals negative b plus or minus the square root b squared minus 4 times a times c divided by 2 times a. So I have x equals negative 12 plus or minus the square root of 12 squared minus 4 times 5 times 7 divided by 2 times 5. So I didn't do this example ahead of time, so I'm going to have to do a little calculations while I'm working here. So let's see. X equals negative 12 plus or minus the square root of 144 minus 20 times 7, which is 140, divided by 10. Okay, I'm going to bring this up here. So x equals negative 12 plus or minus the square root 140 minus 144 minus 140 is just 4, which is a nice perfect square, divided by 10. So x equals negative 12 plus or minus 2 divided by 10. And now I can split. So I'll have my plus and my minus. So negative 12 plus 2 divided by 10, or negative 12 minus 2 divided by 10. So negative 12 plus 2 is negative 10 over 10, which is negative 1, so x is negative 1. Negative 12 minus 2 is negative 14 over 10, which both divisible by 2, so gives me negative 7 over 5. Or I can write, what would that be, negative 1.4. So x equals negative 1, or x equals negative 1.4. Did you get those answers? Did you beat me? All right. So there's the first step, finding the zeros of the function. Well, once we know the zeros, that's the same as our roots. We can write this equation in factored form. So I'm just going to erase this so that I don't have to go to a new page. So I get those zeros, right? So those zeros are telling me where my graph, whatever my graph might look like, let's say it looks like this, those zeros are telling me where my graph crosses the x-axis. It crosses at here, -1, and it crosses at, whoops, here would be -1, and here would be -1.4. So if it crosses at those two places, writing this equation in factored form is really very easy. We have y equals x minus -1.4 and x minus -1. There's our factored form, but we have to change our minus and negative to a plus. And the only other thing I have to do, and of course now I've erased it, is look back at my scale factor. What was my scale factor? What was my a value in this problem? Well, the problem started out y equals 5x squared. So 5 is my scale factor. So that is what goes out front here. Okay, so in that original problem, y equals 5x squared plus 12x plus 7, this is my a, right? And in factored form, this is my a. So those two numbers have to match. These other numbers, the roots, came from what we got when we solved for x. And then remember, we put them in as opposites because the formula is subtraction. All right, so I hope you took lots of good notes. Be prepared for the Do Now quiz, and we will do some practice next time I see you in class. Have a great night.